Imagine you're on a bike trip, and you only know the elevation gain or loss for each leg of your journey. How would you determine the highest point you reached throughout the entire trip? The problem, find the highest altitude, gives us an array called gain. Each element in gain represents the net change in altitude for a specific leg of a journey. We start at an altitude of 0. Our task is to calculate the altitude after each segment and return the maximum altitude achieved at any point during the entire trip. We're looking for a single integer output. A straightforward but inefficient approach involves constructing an entirely new array to store all altitudes. We'd initialize the first element to 0, then iterate through the gain array, adding each gain to the previous altitude to compute the current one. Once all altitudes are computed, we'd then iterate through this new altitudes array to find the maximum value. This method involves two separate passes over potentially large data, leading to a time complexity of big O of n for computation and big O of n for finding the max, totaling big O of n time and big O of n space for the auxiliary array. The key insight here is that we don't need to store every single altitude. We only care about the current altitude and the maximum altitude seen so far. We can track these two values with just a couple of variables. Initialize both current altitude and maximum altitude to 0, because our journey always starts at 0. Then iterate through the gain array once. In each step, update current altitude by adding the current gain value. Immediately after updating current altitude, compare it with maximum altitude. If current altitude is greater, update maximum altitude to this new value. By doing this in a single pass, we continuously maintain the highest point without needing extra storage. Let's trace this with an example. Gain is -5, 1, 5, 0, -7. We start with current altitude at 0 and max altitude at 0. First gain is -5. Current altitude becomes 0 plus -5, which is -5. Max altitude remains 0 because -5 is not greater than 0. Next, gain is 1. Current altitude becomes -5 plus 1, which is -4. Max altitude is still 0. Third gain is 5. Current altitude becomes -4 plus 5, which is 1. Now, max altitude updates to 1 because 1 is greater than 0. Next gain is 0. Current altitude remains 1. Max altitude stays 1. Finally, gain is -7. Current altitude becomes 1 plus -7, which is -6. Max altitude remains 1. After iterating through all gains, we return max altitude. After processing all gains, the final maximum altitude we tracked is 1. This is the highest point reached during the journey, as all other intermediate altitudes were either lower or equal to 1. You'll spot this pattern when a problem asks for a running maximum or minimum value, especially when the current state depends only on the previous state and the current input. It's a classic sign that you can optimize by avoiding full state storage and just keeping track of the necessary aggregate. This optimal approach achieves a time complexity of big O of n because we iterate through the gain array only once. The space complexity is big O of 1, constant time, as we only use a few constant variables. This prefix sum optimization is incredibly common. Try the next problem, same pattern. Don't forget to like and subscribe for more efficient DSA solutions.